my name is Steven Koutstal from Ericsson. I will do a little bit of a story on what the test purposes are. So first of all, we talk a little bit about summarization, why it's important, and what we did in this test. So in this test, we did summarization for loopback addresses and for the locators. Locator TLVs are generated by the ABRs to create summary routes from one area into the other. Next part is what Aditya will show is the UPA, so Unreachable Prefix Announcement. This comes together with summarization in a particularly good way. So summarization becomes much more useful once we have unreachable prefix announcements. And then Christoph will talk about flex algorithm, where it's important on guiding multiple paths through the network based on specific metrics that might differ from each other. Summarization. Summarization becomes a very important tool as networks start to grow. The number of endpoints are increasing. The number of endpoint networks are also increasing. This means that the routing information databases on our routers need to be bigger if we want to address all these address spaces individually. So summarization between areas becomes very important for, first of all, the RIB size in the router, so we can keep the cost down if the RIB size is smaller. This is what summarization facilitates. Also convergence of the network is a lot faster if we don't have to process a lot of individual routes. And I guess the complexity, of course, of the network as well. It becomes much more easy to know if you can look at summary routes rather than thousands or hundreds of thousands individual routes. This is why we ran this test. And I guess for Aditya, it's important now to show that UPA is a critical tool if you want to use summarization to the maximum.
This was the topology that we used for summarization. So as you can see, there are different vendors participating, and there's almost 9 different vendors. The goal here is to show in a multi-vendor environment, how can we leverage the SRv6 principles, do summarization, keep the cost low, and also leverage some of the principles of unreachable prefix advertisement. We will quickly move on to a live demo pretty soon. But if you look at it, the summarization topic that Steven talked about is great, but it does not solve all the problems or all the scenarios. One particular scenario here you see is with, essentially you have 2 egress PEs. In this case, if you look at the right side, there's the S3C and the Juniper. Those both are the egress PEs advertising the same prefix, but what happens is if one of the egress PE dies, because of the summarization, the ingress PE has no idea that the egress PE has died. So we need to figure out a way to signal that announcement to the ingress PE, or we might have to end up waiting for BGP to converge or withdraw all the paths from that particular remote ping. So to do this, what we'll do is leverage the concepts of BGP prefix independent convergence, which is PIC, along with unreachable prefix advertisement, which is basically advertised by the Ericsson ABR in this case. So we will do a quick demo in here where the Juniper egress PE will be disabled. We will get a UPA route from the Ericsson. On the ingress PE, which is the Arrcus, we do prefix independent convergence, which basically means we create an indirection for the route, so that way, no matter what scale you have, you can quickly switch over from your primary path to the backup path. So from an operator perspective, you're keeping your network quite simple at the end of the day, but also getting benefits from all the convergence improvements that the UPA gives you. This has been successfully tested in a multi-vendor environment, so you can be rest assured that everything is standards compliant in here. So let me quickly move on to the demo aspect of it. So this is the Argus ingress PE that I'm here right now. We will showcase basically the locator summary that is coming in. So all the locators have unique prefixes in here, but we are getting the summarized locator, which is /36. So 1000:1000 is from domain 1 and :2000 is from domain 2. We can also show you a couple of locators coming in. On the Juniper ABR in here, you can see there are the locator summarization and the loopback summarization that's being done. So you can see, which is basically your :1000 is for domain 1, and you have the :2000 for domain 2. We're also doing loopback summarization for 2002 prefix and the 1001 prefix. So essentially, you may have a lot of SIDs within your domains, but we're keeping that LSP count down by summarizing that on the ABRs. Now, looking at on the ingress PE, there is one particular route that is that's of interest for us. If you look at this particular route, there are two egress Ps that I've described earlier. One is the H3C and one is the Juniper. So if you look at the first next hop, which is the end UDT4 SID, this is being advertised by the Juniper. The second one, which is the backup path, is being advertised by the H3C. So we will do a quick test right now to see if the remote Juniper device is disabled, how quickly can we converge. But before that, let's quickly look at the prefixes that we have for all the loopbacks from the LSTB. So as you can see right now, we have the summary of the loopbacks, which is 1001:16. And as soon as the Juniper P is disabled, we will see that a UPA route will be received, which is basically a very high metric route in here. So maybe we just go ahead and disable the Juniper P. And we'll also see that the traffic switches over from the primary to backup, all right? So the Juniper remote PE is disabled, and as you can see here, the metric for the Juniper PE, this route did not exist earlier, so the ABR, what it did was it recognized that there was a failure on the domain 2. It immediately sent out a /128 UPA route with a very high metric, signaling the ingress P, which is the Arrcus, to do an immediate switch over to the backup path. So if you look at it, Juniper has collapsed on the domain 2. Ericsson has taken that advertisement, sent it to domain 1, and the ingress P reacts to it. So the net of it, basically what you say is the same prefix that was here earlier now is successfully going over the backup path. Earlier, this was a backup path, but this turned out to be like a primary path right now. So the net effect of it is that when you're an operator, you will have minimal convergence because this is happening in place, and this is independent of any prefixes being advertised in here. So with that, I think I'll hand it off to Anirban to show the traffic statistics. So we have live traffic running in here. So that way you guys can see what the statistics look like.
We also have a PE connected to this topology. So in this, we can see that the ABRs have sent /16 route for this 1001 prefix. Okay, so now moving on to the traffic. So we are sending traffic in this topology from the left side to the right side.
Yeah.
Okay, and we see that the traffic is going on fine. So here we can see that the traffic now is being received on the first 119 VLAN. So we have assigned the 119 VLAN for H3C. So now the traffic is being received in the H3C after the UPA has been triggered.
Correct, that's right.
Okay, so before that, the traffic was being received on the 162, which is for Juniper. Now, after the UPA, it has moved to the H3C router. Yeah, thanks.
All right. So I think with this, we'll hand it off to Christoph, who will talk about the Flex Algo.
Thank you very much. So the last topic for this presentation, this demo, is the Flex Algo. So we discussed summarization, yes, initially. Then we discussed some enhancements for the summarization for UPA, Unreachable Prefix Announcement. And the last topic, which is kind of separate topic from the summarization and the UPA, the Flex Algo. So what is Flex Algo, flexible algorithm? So in segment routing, both in segment routing MPLS and segment routing V6, we can define different algorithms. It's called flexible algorithms. By default, we have algorithm number 0. So this is default algorithm that is, enabled every time. And this default algorithm number 0 means that all topology is taken for the algorithm number 0, and IGP metrics on the links are taken for algorithm number 0. But we can define additional algorithms, numbering from 128, 129, 130, and so on. And these algorithms can be differentiated mainly by two things. First of all, different topology. So we can exclude, include certain links from the topology. For example, FlexAlgo 0 is taken full topology, but FlexAlgo 128 is taken only some subset of the topology because I exclude certain links. These links excluding could be based on the administrative groups, so admin groups, or affinity bits as well. It's got affinity bits. I can include, exclude certain things. Why this is one thing, yes, that characterizing the FlexAlgo. Another attribute that characterizes the FlexAlgo is what kind of link metric should be used for SPF calculation. So normally we use so-called IGP metrics for links. IGP metrics in case of ISIS, the default is 10. So every link has the metric 10 by default in ISIS. Of course, it could be reconfigured to something else. In general, when we talk about segment routing, we support three types of link metrics. So one is this IGP metric, as I mentioned. The second is traffic engineering metric, so it's another number associated with the link. I know an IGP metric, traffic engineering metric could be different. For example, IGP metric could be related to the link bandwidth. So high capacity links have low IGP metric, low capacity links have high IGP metric. Yes, and in that case, the SPF algorithm will calculate the path that prefers high capacity links for IGP metric, for FlexAlgo 0. And for TE, for example, we could have different allocation scheme for the metrics. I don't know, some metrics inside of the country, or links inside of the country have a higher metric, and links outside of the country, opposite. So links inside of the country has lower metric, T traffic engineering metric, and links outside the country has higher traffic engineering metric. And this is FlexAlgo 128, another FlexAlgo. And in that case, the SPF calculation will prefer the path inside of the country, yes, because the outside of the country links has higher metrics. But we support as well, so segment routing in general supports as well third kind of metric, which is link delay metric. And this link delay metric can be associated to the links in two ways. One is the static configuration. So if I know, for example, that my fiber length is, 100 kilometers, 100 kilometers, each kilometer is 5 microsecond delay. This is propagation of the light in the fiber, in the glass. So we have 50 microseconds for 500 microseconds for 100 kilometer length. This is one option, yes, manual assignment. Second option is that we enable TWAMP. So TWAMP for the dynamic link measurement, link delay measurement. And with this TWAMP, we can measure what is the delay of each link. And then based on that, we advertise in ISIS database these link metrics. So which means, again, so summarizing, FlexAlgo can be restricted to certain topology. One FlexAlgo is full topology, another FlexAlgo is a subset of the topology. And for the reason could be anything different, whatever operators prefer. And then FlexAlgo can be differentiated by the link type, by the metric type that is used for SPF calculation. So in our particular case, for our testing, we have enabled two FlexAlgo in addition to the FlexAlgo 0, which is the default one. So we enabled FlexAlgo 128 and FlexAlgo 129. One was based on the delay metric, another based on traffic engineering metric. Each FlexAlgo as well uses different set of locators. Yes, we know for SRv6 we need to define the locators. Locator is the base destination address that is later on used for transporting the traffic. And each FlexAlgo has different locators. So you see here the locators. What kind of locators here for FlexAlgo 128, 129? For 128 we have 5800, 128 colon something. And for 129 we have 5800 colon 129 colon something. So why we use 5800? So 5800 is the address space assigned by IANA, so Internet Authority Number Registry, for locators, SRv6 locators. So a specific address space assigned for the locators, and that's the reason we're using this address space in this one. Yes, based on RFC 9602. And then we are doing summarization here as well. Yes, summarization was already discussed at the very beginning by Steve. Steve mentioned this summarization in the context of the default behavior, I mean the default algorithm 0. In the algorithm 0, the summarization was done using two TLVs. So one TLV is the IPv6 reachability TLV. Another TLV is SRv6 locator TLV. For non-default flex algos, like in our case here, flex algo 128, 129, and so on, locators advertise only using SRv6 locator TLV. So when we create the summary on the ABRs as well, we need to create this TLV number 127. This is locator TLV. And this is /36, the summary, because locator itself is /48. All right. And then, of course, from level 2 to level 1, as well, we have in opposite direction as well summarization of the locators. All right, and then as I mentioned, so delays, so we measure some delays. In most cases, we measured link delay using dynamic TWAMP measurement. So in that case, we verify as well interoperability of TWAMP, so not only flex algo, but as well TWAMP measurement interoperability. So in the past, in the previous years, 1 year ago, 2 years ago, 3 years ago, we have more limited interoperability experience. Now it's going better and better, and more vendors can interop regarding TWAMP measurements. Yeah, so essentially, during this year, almost all TWAMP measurements were done dynamically. All right, and there are a couple of static, only a few of them. So a few of them are static. And then I would like to show now a couple of outputs. So this is the ISIS database output from one of the ABRs, so border routers between level 1 and level 2 ISIS. Because on these border routers, we can see advertisements of level 1, level 2. Actually, I will make more specific level 1 first, for example. Level 1. Okay, so this is what the border router advertises, what kind of locators the border router advertises to level 1. So we have this /36, and we see two fresh /36 locators. Yeah, this is the summary here. So I advertise the summary for algorithm 0. You see here algorithm 0, there's a default algorithm. And then for algorithm 128, 129, we advertise locator, so the summarization is done the locator. And of course, ABR advertise own algorithm, own locators as well. So /48 is the local locator. And the same for level 2. If we check for level 2, so level 2, if I check for level 2, I have similar situation. So ABR advertises local locators for free flex algos, flex algo 0, 128, 129. And then ABR as well creates a summary for, again, for free locators, locator for Algo 0, Algo 128, 129. And then later on, these algorithms are used, or these locators are used by the services. So if the service is like layer 3 VPN or EVPN is mapped to Flex Algo 128, it will use locator from 128. And because of that, it will stay inside of the topology of 128. And the path calculation for this locator will be based on the metric that is specific for this 128, for example, delay metric. All right, and I think that's all what we wanted to show today. So this is largest micro-seat interop in the industry. I think it was 12 vendors, 9 vendors. So here's the multiple vendors. You see Arrcus, Arista, Ciena, Ericsson, and so on. Summarization with UPA, Unreachable Prefix Announcements, so that we can scale the network to the high sizes, because we summarize across the domain boundaries. Flexible algorithm for latency awareness, so we can measure the delays automatically and use one of the flex algo based on the link delay measurements. So dynamic performance measurements with the TWAMP. And then we have different kind of services. A lot of tests was around layer 3 VPN, but we tested as a EVPN, ELAN, so EVPN, VPLS, and VPN ELAN or VPWS, which are private wide service. And as well, all the tests performed at the EANTC this year essentially were using micro seats, so seat compression. So industry is moving towards the seat compression and to minimize the overhead. And thank you very much.